Hello everyone! Today, we are going to talk about sand casting. What is sand casting? As depicted in the picture here, sand casting is a metal casting process during which molten metal is poured into a sand mold and solidified inside the mold that obtains a cavity of the shape. Let's take a closer look into it. Factories specializing in sand casting are called foundries. Here is a foundry with auto sand feed and humidity control. First, a pattern is designed for the mold. Place a pattern in sand to create a mold. Then, remove the pattern, incorporate the pattern and sand in a gating system on both top and bottom half. Remove mold frame and prepare for casting. Pour some molten metal. Cool the metal and remove sand. Get the casting and grind it. And we get what we desire. Sand casting works for metal and alloys. A wide range of molding sand can be used for different materials, including silica sand, olefin sand, chromite sand, zircon sand, and chamois sand. The sand are combined with binders such as clay and water, oil, resin, or sodium silicate. Here are some guidelines to help the process. Sand casting can form complex shape and is able to produce large parts, but it is limited in forming complex shape inside the inner cavity. There are several types of patterns used in foundry practice. The pattern type can be categorized as shown. Each of these pattern types has advantages and limitations. Hence, the selection of pattern type will generally depend on the requirements associated with a particular casting. A sand-casted product can weigh from 1 ounce to large parts even 450 pounds in weight. Max wall thickness is between 0.125 to 5 inches. One of sand-casting's shortcomings is a poor surface finishing and tolerance. The tolerance on allowance varies for different dimensions. Generally, for each additional 25 mm, the dimension tolerance increases 0.025 mm. For wall thickness, tolerance is always plus or minus 0.2 mm. For straightness and flatness tolerance, there is 0.1 mm per 25 mm, excluding localized pattern depressions. And the angular tolerance varies up to 75 mm. Compared to die casting, sand casting can produce very large parts, weigh up to 450 tons, with lower tooling and equipment cost. Long lead time is required to design and construct molds for die casting. Hence, the lead time of the process for sand casting is much lower than for die casting. At the same time, sand casting also has some disadvantages when compared to die casting. Sand-casted products obtain relative poor material strength and high porosity possibility. Tolerance and surface finishing are also poor for sand-casting products. However, die-casted parts have high strength and very good surface finish and accuracy, which means they would have better quality. The production rate of sand casting is low while requiring high labor costs for each product. The die casting process has high production rate and low labor cost. Hence, if the production volume is high, die casting would be a good choice. Typical products of sand casting include tubes, thermal exchanger, engine box, and etc. Products with low production volume, large size, and complex shape are suitable for sand casting. If lower precision is allowed, sand casting is an economical process to choose. One example of sand casting product is engine box. As discussed before, with its complex shape, large size, and low precision required, sand casting is a perfect process for the engine box. Sand casting takes part in low volume production. For a typical foundry, about 1,000 engine box is produced per month. The tooling cost has two main components, the pattern and the core boxes. The pattern cost is primarily controlled by the size of the part as well as the part's complexity. The cost of the core boxes first depends on their size, a result of the quantity and size of the cores that are used to cut the part. Much like the pattern, the complexity of the cores will affect the time to manufacture this part of the tooling, in addition to the core size, and hence the cost. The quality of the parts that are costed will also impact the tooling cost. A larger production quantity will require the use of a tooling material. For both the pattern and the core boxes, that will not well under the required number of cycles. The use of a stronger, more durable tooling material will significantly increase the cost. Modern sand casting often uses 3D printing to make patterns for sand casting because 3D printing offers a lot of advantages. 3D printing is appropriate to produce patterns with complex shape with relative low cost. While 3D printing product is usually less durable, patterns of sand casting does not have strict strength requirements. The creation of a 3D printed object is achieved using additive processes. In an additive process, an object is created by laying down successive layers of material until the object is created. Each of these layers can be seen as a thinly sliced horizontal cross-section of the eventual object. There are different 3D printing technologies and materials you can print with, but all are based on the same principle. A digital model is turned into a solid 3-dimensional physical object by adding materials layer by layer. Thank you for watching. Please leave a comment below. If you like our video, please subscribe our channel for more fun videos.